Hello students, in this video I'm going to present a topic from two last topic, carbon and its compound chemistry. Carbon and its compound. So we start with carbon. The carbon is the first element in group 4 of the periodic table. It has an electron arrangement of 2-4. So carbon has 6 electrons. So the electron arrangement or electron configuration is 2-4. It forms covalent bond in most of its compound. It occurs in a pure state such as diamond and graphite. So carbon in pure state, it is now diamond and graphite, and it's in pure state such as amorphous of carbon. We are going to discuss one after another. It also occurs in the combined state or in a compound such as carbonate, mineral oil, organic matter, and carbon dioxide gas. So here I have a section of a modern periodic table. So carbon belongs to carbon now. It is number 6. It belongs to period 2 and group 4. The first one, carbon. It has mass number 12. It has the atomic number 6. Although it forms an allotrope. Carbon and it is allotrope. Allotropy is the existence of an element in more than one form. The existence of an element in more than one form is called allotropy. Carbon is one of them. It can exist in many forms. In the same physical state, the different forms are called the allotrope. The different form is called allotrope, while allotropy is the existence of an element in more than one form in the same physical state. Carbon has two naturally occurring allotropes, diamond and graphite. These are the two allotropes of carbon which are naturally occurring, and it is pure. Let's start with the diamond first. Diamond is one of the stable allotropes of carbon. It's a colorless, transparent, shiny crystalline solid. Appearance now it's a colorless, it's a transparent, shiny crystalline solid. In diamond, carbon uses all the 4 valence electrons to form covalent bonds. Since it uses all the 4 electrons in the outermost energy level for bonding, it does not conduct both electricity and heat due to the lack of the localized electron, because all the 4 valence electrons of carbon is used for bonding in diamond. Diamond has a density of 3.15 gram per centimeter cube. The high density is due to the continuous loose packing of carbon atom. Diamond has a high melting point of 3700 degrees centigrade. The high melting point is due to the strong covalent bond, since we have said covalent bond is very strong. Diamond is one of the hardest naturally occurring substances. The hardness is due to the uniformity of covalent bond between the atoms throughout the structure. Since the atoms are fixed, are closely packed together, diamond becomes the hardest naturally occurring substance. Diamond has a giant atomic structure in which carbon atoms are arranged in a regular pattern. Yes, I have said diamond has a giant atomic structure which carbon atoms are arranged in a regular tetrahedron. So the shape of diamond, we're going to show it is tetrahedron shape. The whole structure of diamond extends in all directions, forming a ring mass of carbon. It is used as a jewel because of its shiny appearance when polished. It is used in a glass cutter and drill bits because it is the hardest. And here we have the diagram of a diamond. So you see this one is a carbon atom, and here we have covalent bond. This is now the structure of diamond. If you see this structure, remember this one, it is a diamond. Next, the other allotropy of carbon, we go to graphite. Graphite, this is another stable allotrope of carbon. It is black, soft, slippery crystalline solid. Remember, diamond, we have said it is a colorless, shiny, transparent crystalline, but this one it's black in color, very soft, slippery crystalline solid. Graphite is made up of hexagonally arrangement. So this is the shape of graphite. Carbon atom bonding together in layers. When each atom is bound to 3 carbon atoms, the layers are held together by weak van der Waals forces. We're going to see the diagram. Graphite has a density of 2.3 grams per centimeter cube. The low density is due to the spaces between the layers. It is very soft, slippery because the layer in the structure can slide over each other, due to the weak van der Waals forces. In graphite, each carbon atom uses only 3 electrodes in the outer energy level to form a covalent bond with other carbon atom. An electron in the outer energy level of each atom is not used in bonding. Its delocalized, hence graphite conducts heat and electricity. Both melting point and boiling point of graphite is very, very high because of the strong covalent bond between the atom in its layer. Graphite has a giant atomic structure in which layers are held together by weak van der Waals forces. The high melting point and its slippery nature make the graphite as a good lubricant in moving machines, but where a lot of heat is produced. The high melting point also makes graphite used in making mold for casting metals. It has a delocalized electron within the structure, hence is used as an electrode. Graphite is mixed with clay to make pencils, lead, because the carbon layers can slide over each other. Here now we have the diagram of a graphite. Remember, this one is the carbon atom, and here we have covalent bond, and this dotted line is a weak van der Waals forces. Graphite, it only uses 3 bonds. It only uses 3 out of the 4 valence electrons of carbon. The remaining one become the localized electron. That's why we say graphite is only non-metal that conducts heat and electricity due to the presence of a 1 delocalized electron. Here we have 1 layer of graphite, the other layer is here. So these 3 layers are held together by weak van der Waals forces. This makes the graphite to be very soft, slippery, because the layers can slide over each other, because in between them we have a weak van der Waals forces. Graphite has a high melting point. This is because the atoms are linked together by strong covalent bond. Next, now we go to amorphous of carbon. We have done stable allotrope of carbon, that is diamond and graphite. Amorphous carbon, this is impure form of carbon. Example, we have charcoal, we have soot, we have coke, and we have coal. These are impure form of carbon. We call it amorphous carbon. They contain a small amount of graphite. They do not conduct electricity and heat because of the irregular arrangement of graphite crystals in their structure. Amorphous carbon, especially charcoal, has the ability to absorb the gases and liquid. It is therefore used in a gas mask. Charcoal is used to absorb the colored impurities in sugar refining industries. Carbon black is mixed with rubber in manufacture of tires, such as a filler to improve tensile strength and reduce wear and tears. It also gives tires the black appearance. Next, now we go to chemical property of carbon. How carbon burns in air. When carbon is heated, it glows red. So carbon, we can say it glows red. A colorless gas is produced which can react with a calcium hydroxide to form a white precipitate. You see, this one now is the test of carbon dioxide gas. Carbon dioxide gas, when it reacts with calcium hydroxide, another name of calcium hydroxide is called lime water. So carbon dioxide gas form a white precipitate with lime water. The red glow shows that the reaction produced heat. The reaction is exothermic. The white precipitate shows that the gas produced is carbon dioxide gas. When pure carbon is used in this experiment, there is no residue in the combustion tube. Here now we have the combustion tube. When dry oxygen gas passes over heated carbon, we get carbon dioxide gas, a white precipitate. So the carbon dioxide gas passes through these delivery tubes, and once it reacts with calcium hydroxide, also known as lime water, a white precipitate is formed. a white PPT. Make sure that in PPT you write in full in exam. A white precipitate is formed when carbon dioxide gas reacts with calcium hydroxide, because carbon dioxide gas plus calcium hydroxide we get calcium carbonate, which is an insoluble salt. A white PPT is formed. Carbon plus oxygen, we have carbon dioxide gas, and here we have a word equation and a chemical equation. Carbon dioxide gas plus calcium hydroxide, which is a lime water, they form calcium carbonate plus water. The calcium carbonate is insoluble salt because we have said all carbonate are insoluble except group 1 and ammonia. Calcium is not belong to group 1 and calcium is not an ammonia. Therefore, this one becomes insoluble salt, and that's why we observed a white precipitate. Next, we go to reducing property of carbon. When a mixture of cobalt oxide and let me go back to the slide. Reducing property of carbon will be reduced. Let me repeat again once more. Reducing property of carbon. When a mixture of cobalt oxide and carbon is heated, the black mixture turns into brown powder. A colorless gas is produced which form a white precipitate with lime water. So cobalt oxide plus carbon, we get copper metal plus carbon dioxide gas. Cobalt oxide gas will be reduced to form copper metal. In turns, carbon will oxidize to form carbon dioxide gas. So the color turns from black to brown to red brown copper metal. Similarly, carbon remove combined oxygen from zinc oxide, lead 2 oxide, and iron 3 oxide. And here we have the equation: lead 2 oxide plus carbon, we get lead metal plus carbon dioxide gas, and the color we observe the yellow substance turn to gray. Similarly, zinc oxide, which is white in color when we react with carbon, since carbon is a reducing agent, the zinc oxide will be reduced to form zinc metal and carbon dioxide gas. Carbon oxidized to form carbon dioxide gas. The color turns from white to gray. Iron 3 oxide plus carbon, also we get iron metal plus carbon dioxide gas. The color turns from brown to gray in color. Carbon has the ability to remove combined oxygen from some metal. In this reaction, carbon is oxidized to carbon dioxide gas in the metal oxide, and the metal oxide is reduced to metal. And here we take now the reactivity series. The most reactive metal is potassium, followed by sodium, calcium, magnesium, and so on. In terms of competition for combined oxygen, carbon can be placed in the reactivity series of the metal between aluminum and zinc. So carbon we are placed in between aluminum and carbon. That simply means carbon can remove oxide from zinc, iron, tin, lead, and less. The same hydrogen also we can place, if you remember, for molecular plant, reducing property of hydrogen gas can be placed in lead and copper. That means hydrogen can remove oxide from less reactive metals such as cobalt, silver, gold, and platinum. But carbon can remove oxide from zinc, iron, tin, lead, copper, silver, gold, and platinum. That's why carbon we put in between aluminum and zinc. The reducing property of carbon is used in the extraction of metal from their ores. At a temperature about 1200, carbon reduces steam to hydrogen gas. Carbon in turn oxidizes to form carbon dioxide gas. A mixture of the two gases is called water gas. A mixture of hydrogen gas and carbon dioxide gas is called water mask. Carbon reduces hot concentrated nitrified acid to brown nitrogen dioxide gas and water. Carbon in turn oxidizes to form carbon dioxide gas. Hot concentrated sulfuric acid is reduced to sulfuric acid and water, while carbon is oxidized to carbon dioxide gas. Both sulfuric acid and carbon dioxide gas, both sulfur gas and carbon gas react with calcium hydroxide to form a white precipitate of calcium sulfate and calcium carbonate respectively. And here we have the white equation: carbon plus concentrated nitric acid, they form nitrogen peroxide gas. Here we have nitrogen peroxide gas plus carbon peroxide gas plus water. So nitric acid reduces to form nitrogen peroxide gas, carbon oxidizes to form carbon peroxide gas. And here we have the equation: carbon plus nitric acid gas, nitric acid we get nitrogen peroxide gas, the color is brown, carbon peroxide gas and water. The other equation here is carbon plus concentrated sulfuric acid, we get sulfur gas plus carbon gas plus water. Here carbon oxidizes to form carbon gas, sulfuric acid reduces to form sulfur gas. The two hot concentrated acids react with carbon because they are strong oxidizing agents. So God willing, next lesson we are going to start preparation of carbon gas and carbon gas. So I would like to end in this video. Before, let me just summarize what we have learned in this video. This topic is water and hydrogen. This topic is carbon and its compound. We have learned that carbon is a non-metal. It belongs to group 4, first element in group 4. Carbon forms two allotropy, two staple allotropy, that is diamond and graphite. Allotropy is the existence of elements in more than one form. It's called allotropy. Diamond and graphite is the most stable allotrope of carbon. Diamond is the hardest known substance in this world, naturally occurring substance in this world. The 4 valence of carbon in diamond, 4 valence is used for bonding. Therefore, diamond, it lacks a delocalized electron. That explains why diamond is a bad conductor of heat and electricity. Diamond has a high melting point and boiling point because it has strong covalent bonds which are closely packed together. That also explains why diamond is the hardest. The color of diamond, it is colorless, shiny, transparent, crystalline solid. Diamond is used in jewelry, it's used in cutting metals and so on because of its hardness. Then graphite is very soft, it's black in color, slippery. The graphite carbon atoms are linked together by covalent bond, but the two layers of graphite are held together by weak van der Waals forces that slides over each other. The two layers can slide over each other. That explains why graphite is very soft and slippery. Graphite also has a high melting point because, remember, the atoms are held together by strong covalent bond. That makes graphite to have high melting point and boiling point. Graphite is used to make pencils, it's used as a lubricant and so on. Also, we have discussed the reducing property of carbon. We have said carbon can reduce metal oxide, metal oxide. That is that metal that has a less reactive. Metal that are less reactive, carbon has the ability to remove the oxide from them. But more reactive metal, carbon does not remove oxygen from more reactive metals. So we can place carbon below aluminum. Also, we have discussed that carbon reduces nitric acid to form nitrogen peroxide gas and itself oxidizes to form carbon peroxide gas in water. The same, carbon reduces concentrated sulfuric acid to sulfur peroxide gas and itself oxidizes to form carbon peroxide gas. The two gases, that is carbon peroxide gas and sulfur peroxide gas, they form a white precipitate when it reacts with lime water. So wish you good luck. Let's meet in the second part. We are going to start carbon peroxide gas and the preparation of carbon peroxide gas and carbon dioxide gas, God willing.